Okay, stereoisomers, also known as geometric isomers. These are cis and trans isomers of certain alkenes. So just to be clear, these are not the same structural isomers that we saw with our C5H12 model building activity. Structural isomers have different sequences of atoms, much like but1-ene and but2-ene would have different sequences. However, these geometric isomers have the same sequence, but a different spatial arrangement. And the reason that spatial arrangement can be different is that there is a lack of free rotation around the double bond. So the focus for us will always be the carbons of the double bond when we look to decide and understand cis and trans isomers. So I've reminded you here that trans typically means across, so you might think of the Trans-Canada Pipeline or the Trans-Canada Highway, a highway that stretches from Victoria in the west, right out to the east end of Canada. Cis means the same, and so across and the same, we're really referring to where bulky substituents are located relative to the plane of the double bond. So I'll elaborate in a specific example. Consider but2-ene. So you'll notice that I've numbered the carbons of the parent chain, and in both these diagrams you see 4 carbons all numbered in red, 1, 2, 3, 4. In both cases, the sequence is the same, CH3, CH, double bond, CH, CH3. And so that's what I mean by that they have the same sequence of atoms. But there is a different spatial orientation. As you saw in class today, we cannot rotate the molecule around the double bond. So I can't twist carbon 3 around so that the CH3 of carbon 4 is actually above the double bond. And so we need to be able to indicate these different spatial orientations. So my suggestion to you is to first view this structure by cutting that double bond in half and looking at the left side. So if I look at carbon 2, I notice that CH3 is bonded to carbon 2 as well as an H. That CH3 is definitely bulkier than the H. First of all, there's 4 atoms there compared to the 1, but really if you look at the atomic number of the atoms that are directly bonded to carbon 2, then carbon 1 has a higher atomic number than hydrogen would, and that's how you can break a tie if you're not sure in another example. So the CH3 is bulky. Then I start looking at the right side of my green dotted line there, focusing in on carbon 3, the second carbon of the double bond. And I notice that it's bonded to an H and bonded to carbon 4. Carbon 4 then is the higher atomic number, or CH3 is the bulkier group here. Now at this point, my focus shifts from looking at the vertical dotted line there to now looking at a horizontal line. So I'll make this one in red, hopefully that stands out a little bit. And so I'm now looking at the plane of the double bond. Do the bulky green circled CH3s, do they appear on the same side of the double bond or across the double bond? And in this case we have the one on the left being above the double bond and the one on the right being below. And so since across means trans, this is the trans isomer of but2-ene. And so we have trans but2-ene. Now on the right side, you'll see if we go through the same analysis, so at first just look down, imagine cutting this double bond in half and just focus on carbon 2 and notice where the bulky group is that is attached to carbon 2. It's not the hydrogen, it's the CH3. And where now on carbon 3 is the bulky group attached? Focus on carbon 3 and what is bonded directly to that. So look at the right side of the green dashed line. And you'll see that we have CH3 as our bulky group. So now we switch our perspective. So I'll erase this one here, and instead of looking at the green dashed line, so to separate left and right, if you will, now look up and down. So across the plane of the double bond or on the same side? Where are the bulky groups located? And you'll see that both green circled items are above, so I'm sort of forming a C here, and you can see how that C refers to cis. And so this is cis but 2-ene. So geometric isomers are labeled either cis or trans, and you put that word out front. Now, as we keep learning and practicing those line diagrams, I'll just suggest to you that you practice drawing trans and cis but 2-ene here with line diagrams. So I start by orienting the double bond horizontally on my page, and I can label those carbons as 2 and 3 so I keep track of what I'm doing. Now from carbon 2 I need to come up to carbon 1, and then from carbon 3 I need to move down to carbon 4. If you were to turn your page on the side, you realize, yeah, that is like the zigzag that I'm used to drawing. Okay, so we can see the trans arrangement. Now for cis, if I draw again my horizontal double bond, and those are also carbons 2 and 3, then I look back at the structure and realize that carbon 1 needs to come up and carbon 4 needs to come up. So the cis structure could have been drawn like this. That would also be correct. Okay, so the fact that there's the double bond and both bulky groups are below means they're on the same side. There's your cis isomer. Okay, so here's a couple of examples. We'll call this one example A here and example B. Go ahead and name these structures. So definitely find the longest continuous carbon chain that includes the double bond. Don't worry about the cis or trans till later. First, find the parent chain, notice the side groups, construct the name, and then make a decision about where the bulky groups are and choose the cis or trans isomer. So pause the video, give that a shot, and then check back in. So I have numbered the parent chain in each of these examples and circled side groups and constructed the root with the relevant prefixes. And so for example A, we have 3-methyl pent 2-ene. Now I'll look at the cis or trans analysis. And so just like before, I first think of this by cutting that double bond in half and looking at carbon 2. I can see there's definitely a bulky piece going above carbon 2 here and really just a hydrogen below, which doesn't show in the line diagram. Then I turn my attention to carbon 3 and look on the right side of my green dash line there and notice that the bulky group is above. And so I forget now about this green line for the perspective, and now I focus in on the double bond. So where are those green circled groups appearing relative to the double bond? Well, they're both above, so they're on the same side, so that is the cis. So cis 3-methyl pent 2-ene. Now to focus on example B. I first start with that dashed line that comes down through the double bond, and I look at the left side, so carbon 3, and I notice this is clearly bulky and just a hydrogen coming off of carbon 3. So really the bulky side is up at this point. And then I turn my attention to carbon 2. And what I notice is that both of these groups are exactly the same. They're both CH3s. So now at this point there's going to be no cis or trans isomerization here because identical groups are bonded to carbon 2, which is a carbon of the double bond. So there'll be no difference because there is no predominantly bulky group there. And so I'll leave the name of B as 2-methyl hex 2-ene. Okay, last two examples here. Draw cis 1-chloro 2-methyl but 1-ene. And then for part B, trans 3-methyl hept 3-ene. So check in with the video when you've tried both these questions. Okay, I thought it would be helpful to see me construct it, so I'll go through the steps. First, I'm reading the bute and thinking 4 carbons, and then I see the 1 ene, so I place a double bond after carbon 1. That means that I have single bonds elsewhere, and so between carbons, and so I fill those in. I'll number the carbons so that I can tell what's what, make sure I don't mislabel anything. And now it says 1 chloro, so there's definitely a chlorine here, and 2 methyl, so there'll be a CH3 here. So I'll fill in the rest of my hydrogens. Carbon 1 here must have an H. Carbon 2 is already has its stable octet. Carbon 3 and carbon 4. Okay, now I need to show the cis. So I will start with the double bond horizontally on my page and label those carbons. Now, what's bonded to carbon 1? Well, a chlorine and a hydrogen. So I'm already thinking about this bond angle of 120 degrees here. And I can see there's going to be an H and a chlorine coming off of carbon 1. Now, it's totally arbitrary which way I put where I put the H and the Cl at this point. But because I chose to put the Cl up, the Cl is the bulkier group of those two, higher atomic number. Then when I place the atoms off of carbon 2, then maybe I'll illustrate carbon 2 there so we can see that. So coming off of carbon 2, I need to make sure for the cis arrangement that the bulky group is going to go up. So what's bonded to carbon 2? We see the methyl group and carbons 3 and 4. And so making sure that the bulky groups come up to keep the cis arrangement, I bring up the CH2 and the CH3. Carbon 2 also has the methyl group. And so between these two groups of atoms, the CH2, CH3 is bulkier than the CH3. And so you can see as we consider the plane of the double bond, both bulky groups are on the same side. They happen to be both above. You could have drawn them both below, that would be fine. And that's the cis arrangement. So if I'm going to do this in a line diagram, bring my carbons 1 and 2 across horizontally. Then I'll come up to the chlorine, come up, and then zigzag for carbons 3 and 4, and bring the methyl group down on this angle. So when I mentioned the 120 degrees, I'm really talking about this angle here, this angle, 3 times 120 is 360, there's my circle. You don't see it off of carbon 1, you'll see 120 here, but then we're not seeing the bond to the hydrogen, and that's why it's not immediately obvious. So the cis diagram, if you drew it like this, that would be perfectly fine. So now both bulky groups are below the plane of the double bond. Here's carbons 1, 2, 3, and 4 with the chloro and the methyl substituents. Okay, last example, trans 3-methyl hept 3-ene. Pause the video, try it yourself, and then check your work. Okay, so I've drawn the 7 carbons, placed the double bond after carbon 3, and put the methyl group on carbon 3. So now I need to situate the trans isomer. So I'm going to start with carbons 3 and 4 and make sure I number them 3 and 4 and set up that 120 degree bond angle so that my geometry will be correct. So I look at carbon 3 and I notice that there's a CH3 bonded to it. I'll throw that here, and a CH2, CH3 for carbons 2 and 1. Okay, so I've put the bulky group high at this point above the double bond. Now I need the trans isomer. So coming off of carbon 4, I have an H, which is definitely not going to be bulky. And coming off of carbon 4, I also have carbon 5, 6, and 7. And so I'll just number those, 5, 6, and 7. So you can see that I've put the bulky group below the plane of the double bond. And so I've created the trans isomer because if you view across the double bond, I've got bulky groups above and below. So there's the trans isomerization. Just to draw the line diagram, Pause the video if, to give yourself a chance to do it, and then check in with me. Okay, so I draw that double bond horizontally, label carbons 3 and 4, and then I zig and zag for carbons 2 and 1. There's a methyl coming off of 3, there it is. I don't draw the bond to the H in the line diagram, so I can come down for 5, 6, and 7. I will number those so I can see them. What animal does that look like? That is the question. See you tomorrow.